Good day. Our topic for today is about compound curves. So, when you say a compound curve, you just have to remember that a compound curve is a combination of two simple curves. So, for example, we'll illustrate what a compound curve looks like. So, if you have this one simple curve, so we have this simple curve, okay, the tangents are this one and this one. So for this simple curve, this is the center of the curve, and the central angle is represented, let's say, by I1 to represent this first simple curve. And that the chord, no, from, let's say, this is the PC and this is the ending point or PT of this simple curve. So therefore, this is the long chord C1. Okay? And then, this is the length of the curve. So we will have this as LC1. Okay? And then for the tangent of the curve, we have this first vertex of the first curve. Okay? So let's say that is point A, vertex of this first curve, and then this will be PC. Okay? So this forward tangent from PC to the vertex of the first curve, that is T1. Okay? And this one, of course, also is T1. Okay? And then, of course, it has its own radius. You have R1. Okay? So this is R1. And this one here is also R1. Now, compound curve is when after the ending point of the first curve, it will be continued by another simple curve. So that the ending point of the first curve, which serves as the beginning point of the second simple curve, will be what you call PCC. Now, PCC, okay, PCC is what you call the point of compound curve. Okay, so that this is the PCC is the beginning point of the second simple curve. So for this second simple curve, it has its own center of the curve. So it has its central angle I2, representing the central angle of this second simple curve. So this is now the tangent. Okay, so this is the second vertex of the second curve or point of intersection. Let's say that is B. So therefore, from PCC to B, that is T2. Okay, and this is also T2. So that the ending point of the second curve is now our PT. Okay. And then, of course, it has its own length of curve, that is LC2. Okay, and it has its long chord, that will be C2. Okay, now if of course it has also its own radius R2. So this is R2, this is also R2. Kung diri lang kutob, this is just R1, radius for the first simple curve. So this is your first simple curve. This is the second simple curve that is combined together. Okay, so this is now a compound curve. Okay, next. Now, this is T1, tangent of the first curve, tangent of the second curve. Now, we have the, from PC, we have the first tangent. Now, if we extend that line here, and the second tangent to PT, if we extend that line, there is a point of intersection. So this V now is the vertex or the point of intersection of the compound curve. Okay, so if we know that if this is I1, okay, if we consider only the first simple curve, so if this is I1, again, the deflection angle of the forward tangent from the back tangent, this one is also I1. So same for the second simple curve. Okay, so these are the two tangents of the second simple curve, so that this deflection angle of the back tangent to the forward tangent and vice versa is also the central angle I2. Okay, so that if this is I1 and this is I2 right here, if you consider this triangle, okay, now this is now from PC to the vertex of the compound curve. This is TL. Okay, TL is the forward tangent of the whole compound curve. Okay? And from the vertex of the whole compound curve to the point of curvature, let's say that is TS. Okay, so TS represents the tangent, forward tangent of the whole compound curve. Okay, so that TL, as you can see in the drawing, TL, forward tangent of the whole compound curve, is the tangent of the first simple curve plus the length AV. No? So this one we have AV. So T1 plus AV is the, TL equals T1 plus AV. At the same time, the forward tangent, okay, okay, to continue, the forward tangent TS is T2, okay, T2 plus BV, length BV. Okay, so the radius of the first curve is R1, central angle of the first curve is I1. You have here PC, you have point of compound curve, then you have PT, T1, tangent of the first curve, T2, tangent of the second curve, TL, forward back tangent of the whole compound curve, and TS, forward tangent of the whole compound curve, LC1, length of first simple curve, LC2, length of second simple curve, long chord of first simple curve, C1, long chord of second curve, C2, and the radius R2. Okay, so those are the elements of the compound curve. Now, we have here important formula that will be derived from this illustration. So as you can see here, we have a triangle right here. Okay, so this triangle, okay, the rather we also have what you call the long chord of the whole compound curve. So direct distance from PC to PT, this is C. Okay, the long chord of the whole compound curve. So this C1 is the long chord of the first curve only, and C2 is for the second curve. But for the whole compound curve, this one you have C. So if we are to isolate this triangle, so you have here, so this is C1, C2, and then C. So let's say this is angle theta. Okay, so we know that for a simple curve, if this is I1, this is also I1, but this one is I1 over 2, so that this one here is also I1 over 2. Same thing for the second simple curve. This is I2 over 2. This one also here is I2 over 2. Okay, so that this theta here, this theta, we have the whole angle here is 180. So therefore, our theta is 180 minus I1 over 2 minus I2 over 2. Okay, so the value of theta is 180 minus I1 over 2 minus I2 over 2. And if you are to look for C, of course, C1 is still equal to 2R1 sine I1 over I over 2, and then C2 is also 2R1 sine R2 sine of I2 over 2. So if you already have the values of C1 and C2, therefore we could use cosine law to get the long chord C. So for the long chord C, square of the long chord C is equal to C1 squared plus C2 squared minus 2 C1 C2 sine theta, where theta is 180 minus I1 over 2 minus I2 over 2. Okay. Next, we also have what you call the LC. Okay, this is the length of the whole compound curve. So LC will be LC1 plus LC2. Now we also have tangent, common tangent. Okay, T is the common tangent. Now common tangent T is this one. This is the common tangent from A to B. So therefore T common tangent is equal to T1 plus T2. Okay? Now, how do we get TL and TS? Now, if we already have T1 and T2, we need the value AV and BV for us to get TL and TS. Now, the forward and backward tangent of the whole compound curve. So, how do we do that? We will consider this triangle, AVB triangle. So, we have this one. Okay. So, this is PCC right here. This is the common tangent T. O, this is T1. This is T2. And this is I. I is also the central angle or the angle of intersection of the whole compound curve. And this is A. This is B. Okay. So, I is also equal to I1 plus I2. Now, this one here is also I1. And the angle here is I2. Okay? Okay. So, V. So, the angle here is 180 minus I. Okay? Therefore, if we already have T, of course, T1 is R1 tangent I1 over 2. So, pag magkuha tag elements sa isa ka simple curve diri sa compound curve, we use the same formula that was introduced during the discussion of simple curve. So, this is also R2 tangent I2 over 2. So, if you have T1 and T2, then you will have T, which is T1 plus T2. So, in this case, for us to get AV and BV, we use sine law. So, we have AV, opposite angle of AV is I2. So, we have over sine of I2 equals length of BV equals over sine of. Okay, so we have BV, the opposite angle is I1. So, we have sine I1 equals the common tangent T over sine of 180 degrees minus the angle I, where I is equal to I1 plus I2. Yan. So, if you have the value I1, I2, you have the value T and 180 minus I, you will be able to get, using this sine law, you will be able to get AV and BV. So, all these formulas are written or included in the slides, PowerPoint slides of compound curve. Dito gyapon doon pa rin sa module 18 natin na title is horizontal curves. The continuation of the slides, we have a slides about compound curve which discusses everything that I am discussing in this lecture video. Okay, so I think we are ready for examples. So we will start with our first example. So the long chord from PC to PT of a compound curve is 300 meters. So long chord. So let's say this is our whole compound curve. So the long chord from PC to PT, that is the long chord C. of our whole compound curve, and that is 300 meters. Okay? And the angle it makes with the longer and shorter tangents are 12 degrees and 15 degrees. So, if we have this compound curve, of course, this is our PC and this is our PT. Therefore, the long chord C from PC to PT, this is 300 meters. Now, this long chord makes an angle with the tangents. So, the first tangent, the angle it makes is 12 degrees. And for the second tangent, the angle it makes is 15 degrees. Okay? Now, if the common tangent are parallel to the long chord, find R1 and R2. So, we are to get the radius of the first simple curve and the radius of the second simple curve. Now, remember, it was said that this common tangent and the long chord is parallel. If this is parallel, as you can see, if this is parallel, if this is 12 degrees, then therefore this is also 12 degrees. And if this is 15 degrees, since the long chord and the common tangent is parallel, then therefore this is also 15 degrees. This is only the case if, again, the common tangent are parallel to the long chord. Okay? But if dili siya parallel, for example, in this general figure of a compound curve, okay, as you can see here in the drawing, this common tangent and this long chord is not parallel. Therefore, whatever is the angle here is not equal to the angle right here. Okay? So, diri lang only in this example that the long chord and the common tangent is parallel. So, therefore, the given angle here is also the angle here. Okay? And this one also. So, we know that this angle here, this is the first deflection angle of the first simple curve. And therefore, this is I1. And this is also I2. Therefore, we already have the values of I1 and I2. So, what we could use here, since we have the long chord, we will also use the long chord of the individual simple curves. So, this is C1 and this is also C2. Okay? So, if we are to get C1 and C2, pag nakuha na natin ang value ni C1 and C2, let's say we have C1, that is 2R1 sine I1 over 2, and C2 is 2R2 sine I2 over 2. Okay? Makuha na to ang R1 o R2 diri. Kaya na naman, because meron na tayong I1 and I2. So, we will isolate this triangle C1, C2, and 300 meters. Okay. So, this is C1, this is C2, this is 300 meters. Okay, we know that this angle here, as I have mentioned, okay, this is I1 over 2, this is also I2 over 2, then therefore, theta is equal to 180 minus I1 over 2 minus I2 over 2. Okay, so we have I1 over 2 minus I2 over 2. Okay, so that will be I1 over 2 minus I2 over 2. So, the angle theta here is 166.5 degrees. Okay. Okay, next. If we look at here, we know that for example, for this simple curve, if this is I1 over 2, of course, this is also I1 over 2. Okay? So, what is left is if this is 12, then minus I1 over 2, which is 12 over 2, then this one is also I1 over 2. Okay, but this is applicable only for the case where the common tangent is parallel to the long chord. If it was not said that the common tangent is parallel to the long chord, then this is not applicable. Okay, we could not directly say that this angle here is I1 over 2. Okay, so if this is I1 over 2, then that means this is 6 degrees. So 12 minus 6, this angle here is also 6 degrees. So this one here is 6 degrees. And here, this is also I2 over 2, that is 15 over 2. So we have 7.5 degrees. Okay, so for C1, we have over sine, opposite side angle, 7.5 degrees equals, for the long chord, 300 over sine of theta, which is 166.5. So therefore C1 is equal to, okay, you have 300 sine 7.5 over sine of 166.5. So 167.74. And of course, for C2, we have over sine of 6 degrees. By the way, this is sine law. Okay, so C2 opposite angle is 6 degrees. Then we'll have a pair 300 over sine 166.5. So we have 134.33. Okay, so therefore we already have C1 from here. From this equation, we already know that C1 is equal to 167.74 equals 2R1 sine I1 over 2, and I1 over 2 is 12 over 2. Then from this equation, we could get R1. And also in this equation, we already know, or we already solved C2, 134.33. That is also equal to 2R2 sine I2. I2 over 2 is 15 over 2. Okay. So from this equation, R1 is equal to 166 or 167.74 equals 2x sine 12. 12 over 2. So R1 is 802.37. Okay. And then R2 from this equation, that is 134.33 divided by 2 sine 7.5. Okay. 514.57. So these are now the radius of the two simple curves in this given compound curve. Okay, we will now proceed to the next question. Okay, we have this one. Okay, so two tangents intersect at station 0 plus 7.4. A compound curve laid on their tangents has the following data. So natay first na simple curve, ana siya. Okay, Tapos, continue ni nga tangent. Na. So, natay, let's say, na. Let's say, diri ang vertex. Okay, so muna ni ang atong second na simple. This is now our second simple curve. Na. So just remember, if you are going to draw the simple curve, it would be better to draw first the tangents. And then it will always be perpendicular to the radius. Yan. So before you draw this curve right here. Okay. So, you have here. This is our V, and the station is given to be 0 plus 777.44. Okay, and of course this is our PC, this is our PT, and this is our PCC. Okay, next. So, given ang central angles, I1, I2, 31, and 36. So, let's say this is I1, 31 degrees. This one here is I2, 36 degrees. Then, D1 is 3 degrees. So, yan. D1, 3 degrees. And D2 is 5 degrees. So, we are going to get the station PC, station PCC, and station PT. Now, station PC is equal to, kagayan lang, the same concept with the simple curve. Whatever is the station of the vertex, then this is the forward tangent TL, or back tangent rather, TL. Okay, so station V minus TL, that is for station PCC. Now for station PC, for station PCC, you have station PC plus LC1. So this is LC1. So from PCC distance, then LC1, that will now be the station of PCC. So plus LC1. Now for station PT, you have station PC plus LC1. Okay, start here, station, then plus LC1, then plus LC2. That is now the station of PT. Okay, so this is LC2, length of curve, this one, for the second simple curve. Okay, so we already have station V that is given to be 0 plus 777.44, but we don't have TL. But we know that for TL, okay, for this first simple curve, this is T1, and let's say this is the first point of intersection for the first simple curve. So we have T1 plus AV distance. So we have again T1 plus AV. Okay. Sorry. Now we need to get the value or the length of AV. So what we need is to isolate this triangle. Let's say this is the second point of intersection of the second simple curve. So we need this triangle. Yep. A, V, and B. And again, you have here the station PCC. So therefore this is T1, this is T2. And all in all, that is the common tangent T. Okay? So this one here is I. And I is given I1 plus I2. So that will be 31 plus 36 given I1 plus I2. Okay? So our I therefore is 31 plus 36, 67 degrees. Okay? So therefore, this whole angle here, since this is a straight line, this whole angle is 180. So therefore, this angle here is 180 minus I, which is 67. Okay? So we have 180 minus 67 is 113. So this angle here is 113 degrees. And given this is also I1, so again, if this is I1, then the first deflection angle of the first the tangents of the first simple curve, this is also I1. So meaning this is also I1, which is 31. This one here is also I2, which is 36. Okay. Now, ano pang given? Given ang D. And then, it was not stated if it is arc, if the degree of curve is arc basis or it is 20 meter station. So, automatic, if it's not stated, then therefore, we use arc basis. Okay, it's not stated in the problem, so automatic, we use arc basis and then 20 meter distance per station. Okay, so, for arc basis 20 meter station, we know that R is equal to 1145.916 over D. Okay, so for R1, we use D1. Okay, which is given to be 3. So, makuha na nato ang R1. 1145.916 divided by D1 is given to be 3 degrees. 381. So, this is 381.997 meters. And then R2 is 1145.916 over D2. And D2 is given to be 5 degrees. So, therefore, R2 is 229.18. 229.18 meters. Okay, we already have radius of the first simple curve and of the second simple curve. What else can we do? Therefore, we have R1 and R2. We could get T1. Okay, that's R1 tangent I1 over 2. And we know that R1 was 381.97. Then tangent I1 was given to be 31. Then we have over 2. So T1 is 381.97 tangent 31 divided 2. 105.93 meters. And we could also get T2, that is R2 tangent I2 over 2. So, R2 is 229.18 times tangent I2, 36. So, you have 36 over 2. 74.47. So, this is 74.47 meters. Okay. So, if we have T1 and T2, then we could solve for T. That's T1 plus T2. So, that is 105.93 plus 74.47. We have 180.93